Let us see the next category under Unit 2. Earlier, we have seen regarding alkaloids. Now, today, we are going to see about lignans. Lignans are subgroup of non-flavonoid polyphenols. They act as antioxidants and defense molecules against pathogenic fungi and bacteria. They are not present in free form but linked with glycosylated derivatives. It is described as a group of dimeric phenylpropanoids where two phenylpropanoid molecules are attached by central carbon C8. As the lignan structure includes two phenylpropane units linked by C single bond C bond at position 8, these conditioned dimers are called neolignans. Lignans are biosynthesized by shikimic acid pathway via phenylalanine. The lignans biologically active as antiviral, anti-cancer, anti-inflammatory, antimicrobial, antioxidant and immunosuppressive agents. They are colorless crystals, no volatility. They are insoluble in water and soluble in organic solvent. Examples: secoisolariciresinol, lariciresinol, pinoresinol, metaresinol, podophyllitoxin A, naturally occurring aryl tetralenol lignin, food-rich lignans from flaxseed known as linseed oil. Let us see an example of linseed oil under lignans. It is commonly called as flaxseed and linum. The biosource is dried ripened seeds of Linum usitatissimum belonging to the family Linaceae. It is widely occurs in Russia, Canada and United States regions. It is propagated by seed propagation. The propagation is efficient at the rainfall 175 centimeters per annum and in the soil type is black soil. The seeds were sown in October with the help of broadcasting method and followed by the harvestation takes place at the month of February. The harvestation is done by made a cut at stem close to the ground and dried 2 to 3 days. The seeds were collected by thrashing so that the capsules were broken apart. The seeds, after collection, it is separated by winnowing, sieved and packed. The seeds are odorless, the taste is mucilaginous. It consists of 40% fixed oil, 20% proteins, and it constitutes a chief constituent known as linamarin, a cyanogenetic glycoside. Apart from this, it also consists of enzymes known as linase and 10% pectin. It consists of chief constituent known as linamarin. Its chemical formula is C10H17NO6. Linamarin is a beta-D glucoside. It is derived from amino acid valine. It is associated with glucose, that is a glycosamide. Linamarin undergoes hydrolysis in presence of linamarase at beta-glycosidic linkage, results in formation of hydrogen cyanide. Let us see about therapeutic uses and commercial applications of linamarin. It is used in the treatment of scabies. It is nutritive. It is also used as an oil in manufacture of soaps, polishers, etc. It is used as demulcent and poultice. The adulterants were used in place of linseed oil is sunflower oil and boiled linseed oil. So the next category after lignans or flavonoids. Let us see about flavonoids. Flavonoids consist of aromatic ring condensed to heterocyclic ring attached to second aromatic ring B. The structure is known as flavonoid diphenyl propane skeleton. These flavonoids are divided into two subclasses, anthocyanins and anthoxanthins. Anthocyanins are important class of water-soluble plant pigments which gives beautiful colors like purple, blue, red, etc. Anthoxanthins includes flavonols, isoflavonols, flavonols, which represents yellow, white or colorless compounds. These are biosynthesized by shikimic acid pathway via phenylalanine. And here you can see the basic moieties of flavanol, flavone, isoflavone and flavanol. Let us discuss about what are the general identification tests for flavonoids. The very first identification test is Shinoda test. To the extract 95% ethanol and few drops of HCl and magnesium turnings are added so that it produces orange, pink, red or purple color due to the presence of flavonols, dihydroderivatives and xanthines. Next test is sulfuric acid test. Upon addition of 66% of sulfuric acid, flavones and flavonols gives deep yellow solution. Chalcones and aurones gives red and flavanes gives orange to red color. When treated with lead acetate solution, yellow colored precipitate is formed. In addition to sodium hydroxide, the extract shows coloration and later it can be decolorized with the help of acid. Examples under flavonoids are tea and ruta. If you see the tea, it is commonly called as Camellia thea, whereas in the case of ruta, it is commonly known as rue or herby grass. The biosource of tea is leaf of Thea sinensis, which belongs to the family Theaceae, whereas in the case of ruta, it is the dried herb of Ruta graveolens belonging to the family Rutaceae. The tea plants were widely distributed in India, Sri Lanka and China, whereas ruta is widely distributed in Europe countries. If you see the microscopy of tea leaves, we can see the epidermal cells or the wavy anticlinal walls, and it consists of actinocytic type of stomata, especially in lower surface. You can see unicellular thick walled trichomes in the leaves of tea. It consists of two layers of palisade cells with large lignified sclerites occurs at intervals. Clustered calcium oxalate crystals are scattered throughout parenchyma, whereas the ruta leaf bears anomocytic type of stomata, whereas mesophyll contains large calcium oxalate crystals and large oil glands. When we see about the chemistry of tea and ruta, in tea it consists of caffeine, that is trimethylxanthine, theobromine, dimethylxanthine and its isomer theophylline and the enzyme thiase. The caffeine molecular composition is C8H10N4O2. It is 137 trimethylxanthine. It consists of three N-methyl groups at C1, C3 and C7. It is synthesized by purine biosynthetic pathway. Whereas coming for about theobromine, its molecular composition is C7H8N4O2. It consists of two N-methyl groups. Hence, it is 3,7-dimethyl-xanthine. It has a uric skeleton and its one methyl group is in pyrimidine ring and the other in imidazole ring. Let us see about the chemistry of ruta. It consists of glycosides rutin, soralin, bercaptan, graveolin and rutarin. And it also comprises of alkaloids in a very lesser amount, rutalinium, dictamine, rutamine, rubalinium. And it also consists of small amounts of fixed oil, linoleic, stearic and palmitic acid. It comprises of limonene, cineol and myrcene as a volatile oil components. Let us discuss about the chemistry of rutin. Its molecular formula is C27H30O16. Its melting point is 242 degrees Celsius. It is a bioactive flavonoid. It consists of an aglycone quercetin and a disaccharide rutinose bound to quercetin at a position 3, ring C. Upon hydrolysis, it gives quercetin, glucose and rhamnose. It occurs as a yellow crystalline powder. Let us discuss about therapeutic uses and commercial applications of tea and ruta. Tea, it is widely used as a CNS stimulant and diuretic, an important role among the dietary supplements and cosmetics. Its antioxidant, anti-hyaluronidase, anti-inflammatory, slimming, hair strengthening, photoprotective and sealing blood vessels properties. Ruta. It is used as an antitussive, spasmolytic, emmenagogue. Emmenagogue means which cures menstrual disorders. Antioxidant, hair conditioning, skin conditioning and body washes. Let us discuss about identification test of tea. The caffeine can be identified as it is a pseudo-alkaloid. It is undetectable by using alkaloidal reagents. Hence, the specific test, Muroxide test, is used to identify the caffeine. Caffeine, when it is treated with acid HCl, potassium chlorate, it results in purple color. And then, when it is exposed to dilute alkali solution, purple color disappears. Whenever the caffeine is treated with tannic acid, results in white precipitation. The exhausted tea leaves were used as an adulterant to replace the genuine tea drug. So the next part, after lignans and flavonoids, let us see about eglans on steroids. Steroidal or cardiac glycosides. The aglycone part of cardiac glycosides is a steroidal moiety. They are either C23 or C24 steroids because of 5-membered or 6-membered lactone ring respectively. The cardiac glycosides containing 5-membered ring is called cardienolides. The cardiac glycosides containing 6-membered ring is called as buffer-dienolides. The lactone ring in cardienolides contains one double bond. The lactone ring in buffer-dienolides contains two double bonds. The presence and attachment of lactone to steroidal moiety possesses proper cardiac activity. The sugar moiety is attached at C3 beta linkage. Increase in OH groups on aglycone leads to quicker onset of action and enhanced metabolism. The occurrences of cardiololites are highly compared to bufadienolites. Let us see about introductory phase of terpenoids. Terpene is the term known as mixture of isomeric hydrocarbons. Terpene represents only hydrocarbons C5H8N. Terpenoids represent hydrocarbons as well as the oxygenated derivatives, that is C5N. All terpenes are terpenoids but not vice versa. On thermal decomposition, it yields isoprene units. All terpenoids is their derivation from one monomeric structural unit known as isoprene. In terpenoids, isoprene units are attached to another moiety in head and tail arrangement known as special isoprene rule. If you see, this is the head and tail arrangement of isoprene unit, which states it is a special isoprene rule. Classification of terpenoids. Based upon the number of isoprene units, they are classified into different types. Hemiterpenes or isoprenes, which contains one unit of isoprene, whereas monoterpene contains 2 units of isoprenes, representing the molecular formula C10H16. Likewise, sesquiterpenes contains 3 units of isoprene, representing C15H24. Diterpenes contains 4 units of isoprenes, C20H32. Triterpenes contains 6 units of isoprene units, C30H48. Tetraterpenes contains 8 units of isoprene units, C40H64. Terpenoids are colorless and gives pleasant smell. Most of the terpenoids are optically active. Let us see about the chemical tests of steroids and triterpenoids. Both the steroids can be identified by Lieberman-Bouchard test and Salkowski test. When chloroform solution of steroid is treated with acetic anhydride and concentrated sulfuric acid, green color is formed. In Salkowski test, when chloroform solution of steroid is treated with concentrated sulfuric acid, red color is formed. The triterpenoids contains 30 carbon atoms, which is isolated from plants as resins or saponins. The important triterpenoids are squalene, which is acyclic in nature. Let us see some of the drugs which comes under steroids and triterpenoids. Licorice and diasporia. Licorice is commonly called as Yesthi, licorice root and mulethi, whereas diasporia is commonly called as yam and rheumatism root. The biosource of licorice is dried unpeeled roots of Glycyrrhiza glabra belonging to the family Leguminosae, whereas in the case of diasporia, it is dried tubers of Diasporia deltoides belonging to the family Diasporiaceae. The licorice is the plant which is widely distributed in Spain, Sicily and England, whereas Diasporia is widely distributed in India, China and US. The licorice grows in sandy soil which is rich in farmyard manure, and it is propagated by vegetative propagation. The young pieces of stolons containing 2 or 3 buds were selected for propagation. After propagation was done, after 3 to 4 years, the roots are harvested in the month of October, and these roots were vigorously washed in order to get rid of soil and dried under sunlight. If the root is unpeeled, it shows the color yellowish brown, and odor is faint and characteristic. Taste is sweet and shape is cylindrical, and the size it measures about 20 to 50 centimeters. In the case case of Dioscorea, the seeds were propagated, but it took a long time. Hence, the Dioscorea even was propagated with the help of vegetative propagation by the use of tubers. At 30 to 40 days, pruning is done. After 2 to 3 months, transplanted to open field, and the open field should be rich with farmyard manure, and the irrigation have to be carried out for every 10 days. After 2 years in dormant season, the tubers were harvested as the diastinin content will be very high, and then it is subjected for drying. The color is slightly brown, odor is odorless, and taste will be bitter. If you see the microscopic characteristics of licorice, it consists of brown colored cork cells. In cortex region, parenchymatous cells contains calcium oxalate crystals, starch grains. In secondary phloem, lignified phloem fibers are present. Medullary rays are biseriate to multiseriate. Cambium is present. Xylem vessels and lignified xylem fibers are present. Pith is observed in root. Whereas in case of Dioscorea, it consists of corcells. In cortex, parenchymatous cells are present. Collateral type of vascular bundles are seen in Dioscorea. Let us see about the chemical composition and chemistry of licorice and Dioscorea. In licorice, we can see the presence of chief constituent known as glycyrrhizin. In glycyrrhizin, the basic moiety is steroidal moiety. It is a pentacyclic triterpenoid compound. It consists of triterpenoid saponins, glycyrrhizin, which is 50 times sweeter than sugar, and it consists of bitter principle glyceramarin. Apart from this, it also comprises of asparagine and flavonoids, liquiritin and isoliquiritin. In case of Dioscorea, the chief constituent is diasgenin. It is a steroidal sapogenin. Apart from this, it also consists of sapogenase enzyme. In diasgenin, the basic moiety is steroidal moiety. It belongs to steroidal triterpene group. It is the hydrolytic product of saponin and diasgenin. Let us see about the uses of licorice and Dioscorea. Licorice use is anti-gastric effect, peptic ulcer treatment, anti-ulcer, where it alters the mucus composition which increases mucosal barrier to diffuse acid in stomach. Its traditional uses include asthma, pharyngitis, malaria, abdominal pain, insomnia, and infections. Licorice root has been used in daily doses from 760 mg to 15 grams for ulcer and gastritis. Whereas Dioscorea acts as a precursor for steroids, sex hormones, contraceptives. It is used in rheumatic arthritis. It is a steroid precursor used in early commercial production of steroidal hormones, hence used as a starting material for more than 60% of the commercial synthesis of cortisone, pregnenolone, progesterone and other steroids. The allied drugs for licorice is Glycyrrhiza aspera, Glycyrrhiza echinata, Glycyrrhiza hirsuta, Glycyrrhiza inflata, Glycyrrhiza pallidiflora. And the adulterants are Manchurian licorice root, Abrus precatorius. In case of Dioscorea, the allied drugs are Dioscorea floribunda, Dioscorea villosa, whereas Costus speciosus acts as a substitute. Let us discuss about the next drug, digitalis. It is commonly called as foxglove leaves. Dried leaves of Digitalis purpurea and Digitalis lanata belonging to the family Scrophulariaceae. It is widely distributed in England, Europe and US. It is propagated by seeds and calcareous and sandy soil is preferable. Acidic pH of soil is meant for propagation of digitalis. It grows well at an altitude of 1600 to 3000 meters from the sea level, temperature 20 to 30 degrees Celsius and rainfall 30 to 40 centimeters per annum. The seeds were grown in the month of April or March. Later, it is transferred to open field September or November. First year, we can see the presence of rosette leaves, whereas in the second year, we can see the growth of sessile leaves. The leaves were harvested by pricking in the month of August and September in the first year and second year, and the leaves were dried by using vacuum drying, and it should not be dried above 60 degrees Celsius as potency is lost due to chemical degradation. Later it is stored. Let us see about microscopy of digitalis. It is a dorsiventral leaf. It consists of upper epidermis and lower epidermis. Beneath upper epidermis, palisade parenchyma is present at laminal portion. Beneath upper and lower epidermis at midrib region, presence of collenchymatous cells are seen. Beneath vascular bundles, presence of pericycle. It shows the presence of anemocytic type of stomata. The glandular types of trichomes, either bicellular or unicellular head with unicellular stalk is present. Uniseriate multicellular bluntly pointed glandular trichome is seen. Digoxin is composed of two structural features, that is sugar moiety and non-sugar moiety. The R group at C17 defines the class of cardiac glycosides. It contains 5-membered lactose ring at C17 position, which is very important for its cardiac activity. It consists of hydroxyl group at C3 and C14 position. AB ring junction is cis configuration and BC ring junction is transfiguration. C and D ring is in cis transfiguration, cis configuration. Additional hydroxyl group is at C5, C11 and C16 is seen. When we are going to see about the hydrolysis chemical constituents of digitalis purpurae and lyrata. Upon hydrolysis, digitalis purpurae yields digoxygenin, digoxygenin via purpuric glycoside A and B with the help of intermediates digitoxin and gitoxin. Whereas in the case of digitalis lanata, upon hydrolysis, it yields lanatoside A, B and C. Upon deacetylation and leaving out the glucose molecule, it results in the formulation of purpuric glycoside A, purpuric glycoside B, deacetyl lanatoside C. Upon further hydrolysis, it yields digitoxin, gitoxin, digoxin. So, in the next step, hydrolysis, it leaves 3 digitoxose moieties at C3. It forms digitoxygenin, gitoxygenin and digoxygenin. Let us see about the chemical test. The deoxy sugars can be identified by Keller-Kilani test. In Keller-Kilani test, 1 gram of finely powdered drug is heated with 70% of alcohol for 2 to 3 minutes. It is filtered and treated with chloroform. It is subjected for evaporation. Then glacial acetic acid is added. Cooled, addition of ferric chloride and sulfuric acid was done. Reddish brown layers acquires bluish green color on standing. The next test is legal test. 1 gram of finely powdered drug is heated with 70% of alcohol for 2 to 3 minutes. Later, it is filtered and the filtrate is treated with chloroform. Subjected for evaporation, addition of pyridine and sodium nitroprusside was done, which gives red color. Baljet test. 1 gram of finely powdered drug is treated with sodium picrite solution which yields yellow to orange color. Let us see the use of digitalis. It is widely used in the case of congestive heart failure. It inhibits sodium-potassium ATPase, thereby uptake of calcium ions as well as sodium ions are increased. Hence, actin and myosin activity is increased, results in forceful contractions. Traditional dosage starts at 1.5 gram of leaf divided into 2 daily doses. Purified digoxin is typically used at daily doses of 0.125 to 0.25 mg. The allied drugs are digitalis lanata, digitalis lutein, digitalis thapsi, and the adulterants are verbascum thapsus, primrose leaves, comfrey leaves. Thank you for today's class, and we will see the rest of the drugs in the next session. Thank you.